Okay, so work, energy, and power. To find the work done by force, pretty sure work done is equal to force times distance. Yep. Well, actually, to make it sound a bit more fancy, the products of force and distance. Alright, next question. An object is at the top of a ramp at point P. The gravitational potential energy of the object at P is 100 joules. The object is released from rest at P. It travels down the ramp. The kinetic energy of the object at the bottom of the ramp at point Q is 60 joules. Okay, so I kind of just read that, and I didn't. Okay, let me read it again. And when in doubt, just read it again. Right, I'm a bit slow, so I have to read it again. An object is at the top of a ramp at point P. So there's an object here. The gravitational potential energy of the object at P is 100 joules. Okay, so it's got a gravitational potential energy. The object is released from rest at P, so it goes down the ramp. Yeah. Kinetic energy of the object at the bottom of the ramp at point Q is 60 joules. So it loses, so it's 100 joules at the top, and at the bottom is 60 joules. So that means that, what is the average resistive force acting on the object as it travels down? So that resistive force is talking about the friction. What? Okay, so gravitational potential energy. We're not given anything else, so it loses 100 joules to 60 joules. That loses 40 joules. Oh, okay, so it loses 40 joules. Right. If it loses 40 joules, that means that 40 joules is the energy that's like working against. It's the energy of the resistive force. So it's energy that's lost. It's the energy lost due to the resistive force acting on the object. What is the average resistive force that travels down the ramp? So how do I get from joules to newtons? Well, work done is equal to the product force. Oh, so we got the distance. The distance is the distance is 5 meters, right? Or it could be, so there's a vertical distance, there's a horizontal distance, and then there's the component, the magnitude of both, like the actual distance of the ramp. So I'm gonna assume that the resistive force. Okay, so the resistive force acts like that. So that means it's acting in this component. So it should be 5 meters. So work done, which is energy, I could just say energy equals force times distance, which is equal. Okay, and then you can rearrange that. Force equals energy over distance. So 40 joules over 5. Well, yeah, that's 8 newtons. So I'm just gonna say 8. I don't know if that's right, but it makes sense to me. So sodium lamp is rated at Sodium lamp is rated at 40 watts. About 12% of the power is emitted as yellow light of wavelength 5.9 times 10 to the minus 7 meters. How many photons of yellow light are emitted per second from this lamp? So energy, 12% of the power is emitted as wavelength, 12%. Okay. So 12 over 100 times the original wavelength, 12% of the original wavelength, equal 5.9 and 10 to the minus 7. How many photons of yellow light are emitted per second from this lamp? Actually, it's only 12% of 12% of the power. Okay, so it's not 12% of the wavelength, it's 12% of the power. So 12% of, what's it, 40? Well, 12% of 40 is, we got a calculator. 12% of 40 is 4.8. So about 4.8 of the power is emitted as yellow light wavelength. Okay, so power equals, well, how many photons are per second? So if there's power of 4.8 watts and it has a wavelength of 5.9. Actually, let's get the equation. Let's get the equation sheet. It's probably really easy. I need like double check. Quantum physics. Energy equals hf, or energy equals hc upon lambda. So that means, okay, so 4.8 is the energy, right? Because the work done is the same as energy. 4.8 watts equals hc. Wait. No. That's the power. Power equals energy over time. Energy is equal to hc upon lambda. Which is equal to times speed of light over lambda, which is 5.9. I feel like I'm overcomplicating this, but some of these wall markers are quite, I don't know, they're quite complex, so maybe not. Okay, so I got 3.3 3.37 times 10 to the minus 19. Okay, so that's the energy. So that means that the photons, how many photons, well, let's just calculate. Energy equals hc upon lambda. I'm not overcomplicating this. We can find out. 4.8 watts, right? It's got a wavelength. 12% of it. The light has a wavelength How many photons of yellow light are emitted per second from this lamp? Okay. Well, how much is one photon? How do I find that out? Oh, the energy. So I got the wavelength. The energy of one photon is equal to this. Right? So the energy of one photon is equal to that. Uh, 3.37 times 10 to the minus 19. Yeah, I did all of that right. So energy, let's just say energy equals power equals energy over time. So why do I need power? Like, power equals energy over time. Power equals joules per second. Joules is energy. So if energy is equal to the base units, but we're trying to get it per second, energy is equal to half mv squared, kilogram, meter squared per second squared. How do I get to s to the minus 1? Well, divide by kilogram meter squared per second. And well, time. Oh, well, time is equal to energy over power. So let's just, then I could do 1 over time to get per second. I don't know if that's even, I don't know. Just see if we get any of the answers. I mean, it doesn't really make any sense, but energy over power. Okay, I got 7. Okay, 1 divided by that. 1.4 times 10 to the 19. Okay, that is one of the answers, so I'm kind of, I mean, that, like, okay, that's the answer that I got, so I'll stick with that. I don't really know how that makes any, let's just try to, like, think about it, okay? So we have 4.8 watts, that's 12% of the power. It's emitted as yellow-white light, wavelength 5.9 times 10 to the minus 7. So I found out the energy of that wavelength. Now we calculate the time in which the energy of that wavelength like how much energy like per the wavelength, and then I did 1 divided by I don't know, but I got the right answer. But thinking about, because it's per second, and I thought, well, 1 over time, 1 over a second is per second. So the Broglie wavelength of a proton is 160 picometers. Pico, I think that's 10 to the minus 12. Kinetic energy of the proton is doubled. What is the de Broglie wavelength for the proton now? The kinetic energy is doubled. The wavelength is 160. So 2e equals 2hc upon, well, if this side is doubling and it's inversely proportional, so that means that if this doubles, to keep them equal to each other, if this doubles, then this hc and hc stay constant. That means that this has to halve, because it's being divided. Yeah, because if this is getting bigger, then you want this side to get bigger as well. The only way for this side to get bigger is if you divide it by a larger number. So actually it will be 2. No, because if you divide it by 2, that means that you're dividing it by more. Wait. If you're dividing the wavelength by, you divide the wave, you don't times it by 2, because then that means it'll be bigger. You're halving it, like you're doing half of the wavelength. So 160 divided by 2, well, that's just 80. So it'll be a. Getting a lot of A's. Slightly concerning. If only I was getting A's on my actual exam. Okay. An object of mass 0.12 kilograms lifted through a height of 0.60 meters at a constant speed of 3 meters per second. What is the minimum power? Okay, this looks easy. Well, actually, power is equal to energy over time. Energy, where you're given speed, you're given height. Okay. Oh. Energy, the gravitational energy, because it's being lifted. Energy equals mgh. Wait, at a constant speed. Okay, well, actually, let's look. Energy over time. Equations for energy. Well, equations for energy, well, okay, GPE. Let's just write, okay. GPE equals mgh. Kinetic energy equals half mv squared. We have a v, we got a mass, but this one has a h. Which one should I use? It's the minimum power needed to lift the object. So I'm going to assume that it's kinetic. Because the energy actually, it might be gravitation. Is the energy required to lift against the gravitational field? Maybe it's both. I don't know. Don't know how that would be both. Maybe I just add them. You know what? I'm just gonna add them. Okay, mgh plus half mv squared. Well, mgh is equal to 0.12 times 9.81 times h is 0.60 plus half times 0.12 times v 3 squared. You know, now that I think about it, mgh, this is the energy required to lift it. Oh, I don't know. Let's just see what we can see what the answers are after. I don't. It's like weird that they include the speed as well. Half times 0.12 times v squared. Whoa! I already wrote that. What am I doing? Okay. Put it in my calculator, not write it again. Okay. Okay, I got add them up. I got 1.24632 as the energy. Power equals energy over time. We don't even have a time. Oh, okay. Oh, I see what you're. See, I'm so overcomplicating it. Overcomplicating it all the time. So it's actually really, really easy. Why? Well, any time. We don't have a time. But we have a distance and we have speed. Guess what? Speed equals distance over time. Yeah. So, time equals distance over speed. Wow. Distance 0.6 over speed 3. .2 time is 0.2 seconds. Wow. 0.2 seconds for it to reach a height of 0.60 meters. Does that make sense? You tell me. 0.2, okay. 0.2 seconds. That's very small. I don't know. I mean, it's only it's like half. 60 centimeters, it's not that much. So maybe, and it's 3 meters per second. Okay, maybe it's, okay, it's not that ridiculous. 0.6 divided by 3, 0.2. Power equals energy over time. The energy was mgh. I don't know why I got rid of that, but 0.12 times 9.81 as gravity times 0.6. Well, that's actually equal to 0.7. So energy over time, this answer divided by 0.2. 3.5, yes. See, I do know physics. 3.5 watts. See. Just do one more question and then I'll look at the mark scheme. Okay, what the hell? The weight of the load is W. P, Q and R are distances between points X, Y and Z as shown in the diagram. What is the work done against the weight? Crane. Okay, you know, I did a mistake. I didn't even read that. I didn't read the first statement. Ah. Okay. A crane is used to lift a load directly from point X. Okay, so it's being lifted from here to there. Q, P, and R distances. You know what? Let's just look at the answer. Look at the answers for forces in dynamics. See this. Okay, no, it's the wrong one. Okay, for a second I nearly got a heart attack. A work done equals force times distance moved or displacement. So I could have just force times distance moved or displacement. Probably could have been a little bit better there. So work done is equal to the product of force and distance. I got the mark, but I could have been a bit better. I don't know. Okay. Question 2, A. Okay, I got that right. Okay, good. So okay, so you do use the same plane. Number 3, A. Okay. Oh wait, I got that right. Wait, how did I? Okay, yeah, I got that right. I don't really know how I got that one right, but I got that right. 4. 4 was B. How was? Okay, I got that wrong. B, 110. How the hell do you get 110? The Broglie wavelength of a proton is 160 p. If you double the kinetic energy, half mv squared. Well, if you double the kinetic energy, that means doubling the velocity. And velocity is being squared. Half mv squared. If you're doubling the velocity, that means 2v squared. That means, well, 2 squared is 4. That means it's 4v. Yeah, I don't know. Well, I got that one wrong. 5. C. Okay.